Today I will demonstrate you how to perform the planning of complex craniofacial surgery. This patient is affected by a frontoorbital nasal dysplasia. It's a condition which associates an hypertelorism with an asymmetric craniosystosis, which gives this vertical orbital dystopia. To get the value of the required correction, we could compare the abnormal subject with some of our atlas of means normal templates of edge-matched patients. So here I open the corresponding atlas. It's loading, and we will move the templates to put it side by side with the patients, and thus we will be able to make the measurement of the normal side and of the patient. So here we have the handles which will allow to move and put the two imaging side by side. So in the normal templates we will measure the intercanthal distance. We will redo the intercanthal distance in the abnormal size. When you put them in 3D, they may be not in the correct position, so it's better to go to report this value on the 2D slices, on the horizontal 2D slices. So I will open the conventional display, which display a 3D slice, a 3D display, but choose the 3 horizontal, and then we move until we reach the intercanthal precisely. So it will appear, I hope so. Yeah, yes, we have a look here, and there we can locate precisely which we need for the correction of the hypertelorism. For this patient, I choose to make a facial bipartition, and I will set the transparency to these landmarks, and I withdraw 2 lines starting from the nasal spines across the resection landmarks. It will be the limits of our resection, and we will see a little bit on the further how to create the place. So this is the right limit, and now I'm drawing the left limit. Here. understanding. Well, now we have an idea of what we're going to do next. Next, we will use the edit to create a set of skeleton parts, those parts corresponding to the osteotomy. We have done the treatment holes with the eraser set to sphere brush and with edit in free view. And now we will use the scissors tools. I align the two parietotemporal holes on the profile, on the lateral view. Now I can see across, so okay, I can see across, so the two holes are aligned, and I use the scissors to join the treatment holes. That's a way to simulate the creation of a frontal bone flap. Yeah. So here we have removed the frontal bone flap, but we will need for further use, you will need to have the object. So with a threshold tool set to 300 outside odd segment, we will create the frontal flap segment. So when we perform the creating of through the threshold, we have a bit more than what we need, but it's really easy to edit. We will use scissors with a rectangle and erased sides. And here we have the frontal flap. So we will change the name of the segment as the frontal bone flap. Yeah. And now we can start to delineate the right orbital frame. So from the skull minus the frontal flap, we remove everything but what we need to keep. We use mostly the scissor, but it's as you like. You can use the eraser if you like. So we make that step by step until there is nothing left but the hemifacial the right hemifacial flap. When it's over, I used to change the name and to change the color of the segment. And I like to use a red color for the right and the green color for the right. The green color. So I name it and I set the color to green. And okay, so I have my second part. After the frontal bone flap, I have the right orbital flap, and then again I redetermine skull to use except the segment which have been already created. So out of this new segment we will create the left frontal orbital or orbitofacial or orbital frame, name it as you like, hemifacial bone flap or frontal orbital frame. I will keep this late name. So keep on removing the part that don't belong to all part of the osteotomy. Step by step. Again. We have some time to go. Well, so no, it's almost done. Just a late refinement. And for the very late details, the island tool is very effective. So here we got the third part of our osteotomy, the left orbitofacial frame. Small detail to be more precise. And I will give him his proper name and set the color to red for the left side. So now you have the two places of the resection, but we have here a problem. During the use of scissors of the first place, we remove a part of the premaxilla which belong to the right side. You can use the paint tool set to bone intensity range outside all segment, and then you will regrow or recreate what you have rightly destroyed during the beginning of your segmentation. Well, so we create a new segment again with a threshold, and we will just keep the part of the bone that we will need to resect during the surgery to narrow the two halves of the facial skeleton. So here this small part of bone, of interorbital bone, which is to be resected, and we remove it just in front of the foramen cecum. And so here I use rectangular scissor, okay, with everything outside, and then I rename this piece of bone to be resected. And I like the blue color, so I will keep it. Okay, so now you have, oh, I changed the color, I put it on. Then again, for the next time you create a new segment with the threshold tool. Okay, so now we have all the pieces of the skeleton which will resulting from the osteotomy. So since segments are only the volume voxels to which color has been attributed, you need to create some models out of the segment. So this is to perform in the data module, right click on the segment and you get the volume created. So you turn off the segment and just keep the volume on display. And now you will be able to move the module. So in the data module, right-clicking down on the color square of a model, create a transform which will permit to move the model here, and it creates, and you have the handles which permit to move the model. So I prefer to move the handle by holding the option key and moving, and it's just on the axis of the rotation. And so I do the correction, and it gives an anterior posterior displacement which has to be corrected as well because of the obliquity of the osteotomy. So here I fix this problem for the green, and I will do the same. So small correction. Okay, it's correct. And now I will move. I hide the handles of the displacement of the right side, and I activate a new displacement of the left and move the handle as well by holding the option key and to put it on the axis of rotation and make the rotation to correct the hypertelorism. Okay, and again I have to correct in the all the orientation and move forward. Okay, so that's good. It's compliant. So we got it. There is a vertical displacement. I'll fix it very easily. Okay. Now we will need to move the frontal bone flap as well. The same by right click first to turn it on. So now here we will choose another way. We will just turn on the segment of the frontal flap. We will turn the segment of the frontal flap because there we need some change to the frontal flap, and it's more complex. We can quite transform the models, but it's more easily done on this segment. So I have turned on the segment of the frontal bone flap, and then in the segment editor, I will perform the small triangular resection to make the adaptation between the frontal bone flap and the orbital frames on both sides. So here I make a resection to the frontal bone flap on the right side and then on the left. And as you can see, I use the scissors. Okay, so it's done for the pleasure of the refinement. I will to complete the trepan hole. And then when I will have finished the correction of the frontal segment, I will export in the data module only this new modified frontal bone flap as a frontal bone flap modified model. And so here I export the model and I put this model in my folder of osteotomies models, and I switch off the segment and I will open a new displacement by a right click in the square color of the model, and here I displace the model. Okay. Thanks to the malleability of the bone in this patient, the discrepancy lateral between the bone flap and the frontal bone flap will be corrected simply by an osteosynthesis, and it's sufficient malleable to push a little, to rotate a little this bone and to correct this problem. So we have simulated everything, but remember that we have a vertical dystopia in this patient because of the beginning of the craniosynostosis as plagiocephaly in the early patients at the first sign of the disease. And we will compare the distance from the bone flap to the orbital rim we take the measurement, we measure the difference, and we will correct the vertical dystopia by resecting the corresponding value in the vertical part of the right orbital frame, and then move it again. So here we use the scissors on the segment to resect this value of bone. I have reported the value. Go to the segment editor, get the scissor tool, set as free, and I make the resection. So it's done, and I will just simply move on the next step. I will move the model. I will move the model to correct the vertical dystopia. Here it's done. So now we have corrected all the deformity corresponding to the condition of this patient. And we can see that it is feasible and that we reach correct anatomy. Thank you for your attention.